right, currently the board is working.
Yeah.
All right, let's not jinx it. Hopefully it will continue to work. All right, so what is KMT?
That all particles are in motion.
All right, the idea that particles in matter are in motion. All right, it doesn't matter what state of matter, but particles in matter are in motion at all times. All right, what conditions are needed for an ideal gas? Non-polar, low pressure, high temperature. All right.
I was about to write all five.
No. I didn't ask for the 5 assumptions.
I know that's back, so now I gotta write. That's what
Now, if we did have a quiz today, notice the agenda's back on the board because the board seems to be working. I would never ask you to write the 5 assumptions. Now, would I ask you to know the 5 assumptions in multiple choice, as in which of the following does not belong? Yes, I would not ask you to list the 5 assumptions. All right. Now, I would ask you to know what the conditions are for an ideal gas. I don't think that's unreasonable. Now, what are 3 properties of gases? Fluidity would certainly be one. All of those things you're yelling out are correct. So expansion, compressibility, low density, diffusion, and fluidity. Any of the 3 are acceptable. All right, number 4 is the only math problem I put on the board. So you should be able to do this based on last night's homework. Now, the reason that I gave you last night's homework is because all of those conversions in the gas law problems at this point in the semester are a standard deduction. All right, we always talk about partial credit. I give partial credit in these gas law problems. However, if it's a 10-point question, if you convert wrong in something, it's an automatic certain deduction. I don't care if you show me the work or not. It's just a standard deduction. You should be able to do these without difficulty at this point. Now, KPA has what number associated with it? And millimeters of mercury has what number associated with it? 760. Okay? Now, at that point, it should just be a matter of using the calculator.
What is 760 and what we go?
101.325. I got 60.6. Anybody else get that?
Yeah.
I think KPA. Now, we talked about yesterday, as long as your significant digits are within 1, I'm not going to get bent out of shape about significant digits at this point. Your unit never goes away. If you forget a unit, I will always take off. Okay?
Oh.
Number 5, what's an elastic collision? All right, no net loss of kinetic energy. The energy is transferred. Everybody okay with 1 through 5?
Yeah.
All right, if we'd had a quiz today, it would have looked very similar to something like that.
I probably would have failed because I had to look at my notes a little bit.
I look at my notes a lot, so.
Okay, well, it's probably a good thing that Ms. Wall was not feeling the urge to grade anything today.
Miss Wall, I'm gonna check my grades.
Miss Wall.
I can hear that. Hush.
Is it like with like the key and everything?
Which one?
Like which one to put on top, like which unit?
Oh, the one that you're going to goes on top, and the one that you're getting rid of goes on the bottom. So since we have millimeters of mercury here that they gave us, that automatically goes to the bottom, so it'll cancel out. And the one that you want goes on top because that's where we're going to. Okay, in terms of what number goes with what, you remember yesterday when we wrote the numbers down, whatever number is with that unit goes beside it. Okay? Anybody else? Now, did everybody find where the numbers are on their orange reference sheet so you know what you have to memorize and what you don't? Hey, pull out your orange reference tables.
What? We have wait. We have to remember that.
That's why I'm telling you, pull out your orange reference tables. Find your orange reference tables. At the very top of the orange reference table on page 1, right under where it says 1 mole, you see where it says gas constants? All right, and then it says standard pressure.
Yes.
We're going to learn how to use all of those in the remainder of that table over the next week or so. All right? So if you look where it says standard pressure, all right, it says 1.00 ATM. That's the number for ATM.
Oh.
All right, and then it says 101.3 KPA. There's your 101.3 for KPA that we just used. All right, 760 mmHg and 760 torr. What is the only one that is missing? And I told you it was missing. Pascal. PA is missing.
That dang lizard.
Now, you can change KPA to PA the way we learn. How do we learn?
Great question.
Kilo.
What? I heard it over there.
Kilo.
You know kilopascal. KPA is kilopascal. You can use what? I heard it over there on that side and this side. King Henry. All right. So you could take this. Let's just say you knew how to do this, and you had to go to PA. Draw your chart a little longer, and go KPA to PA. Right? Who's bigger?
Kilopascal.
Kilo.
How many spaces between kilo and PA?
Where is P?
Three.
The line?
On the line.
I didn't know. 3.
And then you could just convert that way. Now, I think that's a pain in the butt, so I know the conversion, but I've done this a long time. But that's a shortcut if you forget and you need it. All right, now let's talk homework. All right, question 1. Homework.
Oh.
As soon as I find it. Oh, and by the way, we have a CFA tomorrow. It's 14 questions. Common formative assessment. Because I get to design it. It's supposed to be for the whole year, and I didn't make it for the whole year. I made it for the last 3 units. Nope. But I'm going to do it like last time. I'm going to offer bonus points. All right. There it is. So number 1, 311 kelvins. Nikaya, Annabelle, shut up. Number 2, negative 148 degrees Celsius. Number 3, 1.25 liters. Number 4, 0.04175 liters. Number 5, decimal 169 moles. 6, 15.2 grams. 7, 6.33 times 10 to the 4th pascals. 8, 935 torr. 9, 389 kPa. And 10, 1.69 times 10 to the 4th PA. All right. Number 7.
I got regular numbers for Pascal.
475 millimeters of mercury. We're going to pascals. All right, what goes on the bottom?
760.
Millimeters of mercury. Pascals on the top. What number goes beside millimeters of mercury? What goes beside pascals? 1.01325 times 10 to the 5th.
Are you doing number 7?
Yep. So when you punch that in your calculator, you have 475 times 1.01325 second EE5, and then divide 760. I got 63,328.
Oh.
Now, we've talked about the fact that that number being in the tens of thousands, we should do what with that?
Oh.
So if you got that, there's nothing wrong with your answer. But again, 1, 2, 3, 4 places. So 6.33 times 10 to the 4th PA.
So number 9 is.
Number 9 is KPA.
No,
So 389 KPA.
what about the? Cause I got 389.
Oh, the one about
1,088.
All right, that's not right. Not if you got 389,000. You have 3.84 ATM.
Yeah. Oh, it's supposed to be 76 at the bottom. Or is it 1?
KPA. What number is beside atmospheres? 1. On your chart, what number's beside atmospheres? 1. Okay. KPA is 101.325. And then multiply. No. No times 10 to the 5th. KPA always has 101.325 beside it. PA has 1.01325 times 10 to the 5th. Okay, it depends on what number you're using as to which number you get. If you've got PA, you don't use that times 10 to the 5th. If you have KPA, use that 101. Number 10 is 1.69 times 10 to the 4th.
Whoop, sure didn't get that.
You need me to do that one?
No, I know.
Okay. Number 4. All right, 41.75. What do we know about centimeters cubed? It's the same as milliliters, and we want to go to liters. So milliliters to liters. Who's bigger, a liter or a milliliter? A liter. So we put 1 beside that. King Henry died by drinking chocolate milk. So if we know that
King Henry died by
that liters is here, okay, liters is there. So 1, 2, 3 spaces. Then we have. Anything else on the homework?
Kevin Ham died by.
Number which one? 8?
I just want to know anything.
935 tour. Anybody else?
I'm still getting.
Kevin had died lately.
So you want to run significant digits?
I told you, as long as you're within 1, I will not get upset.
This is just
So, you know,
Which one are you getting wrong?
no, you're on the same one. I got it.
Are you sure?
They're good.
Okay.
Yeah.
Anybody else? Question on the homework.
No, man, I had no turkey.
All right. Now, we're going to learn 4 gas laws today.
Yeah.
Maybe 5, but at least 4.
No, I'm about to learn how to sleep.
Go ahead. Here's the counter. Knock yourself out. One less
Jay
person.
Lussac.
This is man's last name. All right. So we're going to divide the gas laws up into 2 sections. Largely before and after break, just because of the way the dates fall. Before break, we're going to do the gas laws that have no mass, no moles. Okay? So today's gas law problems will not have any grams or any moles, nor will tomorrow's. Okay? It's very possible on Thursday we may get started on grams and moles types of gas law problems. So
How long is this law? Is it a lot or is it mediocre?
it's not very long.
You think I can fit it in that space?
All right. Now, so we're going to do the gas laws that have no mass and no moles first, and then we'll do the gas laws that have mass and moles, and we'll bring in stoichiometry at the end. All right. That's the way I've divided them up. So Boyles' law is going to look at. Change colors here. We're going to look at pressure and volume at constant temperature.
You happy you can write on that board again?
It beats this whiteboard over here, or half of it. Now, when we talk about Boyles' law, all right, First of all, we're going to consider a gas moving around inside some container. And it doesn't matter how many dots you draw inside the container, simply because what did I tell you about the amount? The mass or the moles?
It don't matter.
It doesn't matter. They're going to stay the same. Okay? The amount or the moles will be constant. And it will be that way throughout the day. It's not going to change. Now, we've already said that the temperature is going to stay constant. So we'll just leave it at 25 degrees Celsius. Now, before we can talk about the gas laws today, one of the things other than calculating you have to know is how the gas laws work. So before we can talk about how pressure and volume affect one another, what creates the pressure inside of the container?
How many atoms?
Yes, and we need something beyond that.
Space.
Need more. But I don't expect you to be the only person who answers me either.
Molecules. Air.
What? Wait, what? How's it going?
What creates the pressure inside the container?
Air? The temperature.
What do the molecules do inside the container to create the pressure? They move and do what?
Breathe. Create heat. Vibrate.
They knock on each other.
They do what, Takira? All right. Particles collide with each other. That's one piece of it. And what else? It's only a small piece. What else do they collide with?
The wall.
There you go. And the container walls. All right. So pressure inside of the container is created when those molecules hit the container walls and each other. So as these molecules hit those container walls, we're creating pressure. Everybody with me on that?
Yes. Nicole, what is the black writing right there? What is that for? Like, what does that say?
The amount or the moles inside the container is not going to change. Okay. So I don't know how many dots I drew in there. So in a minute, I'm going to draw some more dots. I'm not counting the dots. Just know that the amount's the same.
Hold on. Don't do it.
All right. So
Slow.
what would happen
Let's go with.
if we shrink our volume and we cut it in half? Okay.
It would still have the same.
Our volume has been cut in half. Okay. So the volume is now half the size. The temperature did what?
They stay the same.
Stayed the same.
Shouldn't the pressure stay the same?
So the question is, what happens to the pressure when the volume is reduced? And I'll blow this up in a second for those of you at the back,
Thank you.
if everyone has the
Pictures.
pictures drawn.
Should it should increase? I mean, it's less.
Everybody got the picture?
Mm,
Okay. Got the picture and I can blow it up for the people at the back. Do we have the picture now? Yes? That's not what I meant to do at all. So what happens to the pressure when volume is reduced?
It might, it's up, I don't know.
All right, so Nikaya said what a minute ago.
I think it's gonna increase.
All right,
There's less space, so they're more likely to touch each other.
that's right. All right, so Nikaya said there will be less space. So they will collide more often.
Is that when volume is reduced?
Mm-hmm. So if there's less space and they collide more often, pressure will increase.
Oh.
I want to see what I had there.
Hold on. I go up a little. I could not.
Why are you just taking pictures and not writing this down?
Because I couldn't see.
You said A and
Yes.
T is a
Oh.
mount.
Open the board.
I said,
You said A and T is a mount right there?
AMT's amount.
What are you?
I have no idea what she's doing.
Can't do. She's just taking a picture because she can't see it from the thing.
thank you.
You can't
That's
see
what I was saying.
Wouldn't want you to put it back where I had it and everything.
Oh, sorry.
Is that good for those of you in the back?
Yes.
Pardon the interruption. Please dismiss the members of the men's golf team at this time. Please dismiss the members of the men's golf team at this time.
Every day, early as heck.
I'm telling you, golf is important.
Golf
takes
forever.
I don't even know how to do it, but I'm going.
Well, what?
But people were doing that because everyone's parents was in West Davidson. Sorry, don't care about golf. Everyone just does it because they know how early they get out of school. And whenever I went to that match that one day, no one, people were, it was hilarious. They literally, one dude threw the ball up and hit it like a baseball.
What the
Well, I
world?
went to eat yesterday, and they think I was.
I
mean,
All right, we there? All right, so what is this relationship? All right, did you hear what Jayla said? Inversely proportional. All right, so pressure and volume are inversely proportional at constant temperature, and I'm going to put and moles in parentheses here, because remember, we're not changing moles at all. Moles are staying the same, but it's constant temperature. Now, this has a formula that we're getting ready to use. Remember, these are gas laws, they're math. So our formula is P1 V1 equals P2 V2. Now, we're going to have no temperature in the formula because what did we just say about temperature? It's constant. Temperature's not going to change, so temperature is going to be constant. So, because it's constant, it's not in the formula. So as we progress through the day, and we have 4 formulas, tomorrow some of you, particularly those of you who are less math-minded, you're going to be like, well, I don't know what formula to pick. All right? If the question does not give you temperature, or it says temperature is constant, this is the formula you want because what's not in the formula? Temperature. Okay? That's how you know. Does that make sense? Okay. Does everybody have what they want? Now, the only catch to this formula while Rosanna's catching up is, and I won't have to write it in the word problem this way, the only catch is that, how on earth is it that wide? All right? Is the units must match. That's the only catch. All right, it does not matter at all if you do them in ATMs, you do them in torque, you do them in KPA, you can do it in liters, you can do it in milliliters, as long as the units match. Okay, which is why I said earlier with the homework that the units and the converting was important, because the first couple questions that we'll do today are largely going to match because we're just learning how to use the formulas. But after we get our feet wet with that today, tomorrow, what do I like to do? I switch them up, so I'm going to give you a little bit. The first quiz is Thursday. All right, yeah. You got a CFA tomorrow. CFA is 14 questions. We're not spending a lot of time on that. All right, but outside of the CFA, all right, when we do problems like this for me, I'm going to give you stuff that doesn't match, so you have to do unit conversions and make them match. Okay, that's why I gave you last night's homework.
P and B can be KPA. Is that what that is?
Yes. So P, I might give you a KPA for one P and give you a PA for the other.
And then you have to convert.
And you have to convert one of them to match the other.
And then, so you apply the law to it.
Yes. All right. Now, I would only write one sample problem for each law. Okay? There's Boyles' law. And I'll give you a minute to write before we work it.
Oh, we gotta write this one.
You don't have to write anything. Not like anything.
This is the question.
What's some keywords?
Huh?
What's some keywords?
What do you mean some keywords? You mean figure it out?
Pretty much.
I will do that when we solve.
All of them, right? You're trying to say she went to school with those. No way. Yeah, but what about her and our son? Yeah. 2016, so I was a freshman.
Who was the one that takes?
I was too scared to say that, so.
Right. Who was that person that takes me? Who?
You somebody
Yeah. Like who?
and then
I mean, even Benjamin. And he supports Russia. So. Yeah, he is.
It's a long story.
He's where he
He's
raised.
lucky.
He's where he look. He raised to be y'all. He be talking about, oh, she thick. Like, okay, bitch. I be getting him. I be coaching him. I know you know.
He said, I will be a fine Russian person.
He won't go. Benjamin is
Well, he did it.
But how they inversely proportional if they're constant? Miss Walsh?
What?
How are they inversely proportional if they're constant? It's like
Yeah,
two.
only temperature's constant. Only temperature's not going to change. So the particles aren't moving any faster. The next two is going to have temperature changing.
So only temperature is constant.
Only temperature's constant.
And then
So if you lower the volume,
it's like 2 and 4.
yes. All right, do we have it written?
No.
Yeah.
I'm on the last.
Now, for those of you who are still writing, notice that it says on the last line, what?
The temperature remains constant.
So, who was it a minute ago? Was it Malaysia that asked me to point out some keywords?
Because I didn't feel like writing the whole thing down, but
Oh,
she wanted you to.
okay.
Yeah, that's what I wanted.
Now, sometimes the word problems will say, if temperature remains constant.
Oh.
That right there is what tells you that it's Boyles' law.
Yeah, keyword.
Okay? Now, if it doesn't say if temperature remains constant, and it leaves temperature out altogether, that will also tell you it's Boyle's law. Now, the gas laws are why I push units all year long. Because sometimes it doesn't tell you what things are, and you have to figure it out. Now, in this one, I did tell you what everything is. All right? If you look at the question, it says occupies a volume of what? So I use the word in front of the number. Sometimes the questions don't say that. If they don't say that, then you have to know what this is, because sometimes it won't. Okay? So when you look at it, look for words of possession. So see how it says volume when, we change colors here. Go away. I used to have an arrow that I could tap, but with the other,
Right.
just move down here out of the way.
Just use the, yeah.
There you go, move. All right, when its pressure is 720. See how it says volume, Micaiah, Annabelle. When its pressure is 720, so that 150 has to stay with what number? The 720. So what is the first volume? 150. Now, it does not matter if we make this volume and this pressure V1 and that P1, or if we make it V2 and P2, as long as these two things do what? Stay together. Okay? They don't have to necessarily match right now. I'll talk about the matching stuff in a minute. You see how the wording says volume when its pressure. It shows possession. That 150 has to stay with a 720. Now, what's a milliliter? Is a milliliter a volume or a pressure? That's why I labeled it volume. Millimeters of mercury, did we learn that was a volume or a pressure yesterday? That's why I labeled it pressure. Now, I make them ones instead of twos because where are they in the problem? Are they first or are they second? That's why I made them V1 and P1. You could choose to do it any way you want to. All right, when I keep reading, it says what volume of the gas. So I'm solving for volume. So I'm making my question V2. Occupies a pressure of what? 750. So I'm looking for P2 to be 750 mmHg because that's what they gave me. Now, that stuff that I gave you a second ago about it has to match. Convert if those two things match. No. So if they have to match, V1 is milliliters. So what does that mean V2 is going to turn out to be? That means my answer is going to turn out to be in milliliters. So if my question said what volume in liters, what would I have to do at the end? I'd convert. Does it say that?
No.
It just says what volume. So all I need to do is find my volume, and it's going to turn out to be in what unit? Milliliters. Now, this is the part of the problem where I just write down my formula, and I refer to it affectionately as the plug and chug part of the day.
What?
Plug and chug. All you have to do is plug in the numbers and chug out the answer. You've done all the chemistry. P1 is what? P1 is, so I put 720. V1 is 150 equals, what's P2? 750. And what's V2?
No.
We don't know. Nothing. V2. Now, how do we find V2?
Divide the total.
By,
750.
now, you will never see me pick up a calculator and solve in class until I've solved for V2. So we divide by 750. We divide by 750. Now we can solve for V2. So, solve. What do we get? 100 and what? V2 is 144. And we already found the unit, and it was what? Milliliters. Everybody okay with that?
Definitely not.
Why not? What's wrong with it?
I just looked at it and saw that you had all of this
You looked down and I had done all that, really? I think that's an exaggeration.
that's the matrix. What are you talking about?
I'm tired.
Say, y'all are gonna need to suck it up and get over it.
I think
This is blowing.
Right.
All right, you got it, Faith? All right, try that one. You don't have to write it, just try it. You just did one, so you solved that time. Annabelle, if you don't get off your phone, I'm gonna have your phone until 11:40.
Sorry.
we don't have to write this whole question down.
I wouldn't write any of it. You already got a sample.
I think
Just solve.
This is too much.
It is not too much. It's
I
solved.
can't even read it.
Yes, because I wrote it in French.
Girl, you see that? You see that? That say French law, not French.
Yep.
Altitude ain't volume, so what we finna put?
but just don't worry about it. Just don't worry about it.
Just guess. What was the answer for?
All I know is to follow whatever says volume.
That's all I got right now.
What does this have to do with molecules?
I mean, that's not that
Are we supposed to do anything for this 1:45?
No.
I don't know something up. I know I didn't know that.
Where did you get your picture from?
Actually, it's 0.5. My bad.
Alright.
What does the altitude have to do with all this?
Nothing.
Yes,
Where are
sir.
you gonna see? Now this is what I'm like.
So do we have it?
No,
Yes.
because
Yes.
Okay, never mind, people don't.
I think I plugged in the right things, but I don't know where you get the temperature from. Why? It's called
Annabelle.
There is no temperature.
Huh?
This is
It
why
says-
you should not
it says-
plan a
I know.
photo on TV.
No, it says because it says assuming the temperature remains the same. Well, so
that's-
obviously
that's
you
how
need
you
the
know it's-
temperature.
That's how you know. No, that's how you know it's Boyles law.
Formula to use.
That's what I mean.
Why? Because of this.
All right.
Whoa.
So what do we know? All right. What's my first volume?
500.
Okay. Let me change colors. And so this is V1.
Right?
This was what?
P1.
B1.
All right. So that's V1 and P1. So V1 is 500 milliliters. And P1 is 1 ATM. See how it says in the question, at a pressure of 1? It shows possession. Do I need to know the altitude?
No. Right, that's why I didn't look at it.
Exactly.
Be in the sentence.
Now, they might give you all kinds of junk. It's not important. All right, what else do they give us? 0.5 is what? That's P2. So what am I solving for? Solving for V2. All right, do they match?
Yeah.
Yeah, they match. We don't have to convert anything. So what's my formula? P1 times equals, all right, so my P1 is, V1 is, now, it would not matter if you had flipped those because they're multiplied, so it wouldn't matter. And then P2 is, and then we're solving for V2, so what'd you get when you solved? And what unit did you put on your volume? Milliliters, you're solving for volume. If you put ATM, I would take points off.
You just put V2?
Yeah,
Oh.
milliliters. If you just wrote milliliters, I'd be fine. You don't have to write V2.
I just put V2 because
That's fine. Now, if you don't have milliliters, I will take off.
You have to put V2 milliliters.
You got to put milliliters. I don't care if the V2's there or not.
Oh, that's
The milliliters has to be there because that's the unit. Okay? All right.
So what's gonna happen when we gotta convert?
Convert what?
You said they match for right now.
Okay, so let's say for a second that this one was in ATMs and this one was not. Let's say this one was in KPA. So you had 75 KPA.
What we did, convert like we did on homework?
Gauss' law is volume and temperature at constant pressure.
So volume, temperature, and pressure.
Yep, because what did I tell you about moles?
No idea.
What did I say a little bit ago? We were not going to do what to those?
I have no idea.
We were not going to change the moles right now. They were going to stay the same until roughly after Easter. Possibly late Thursday, but most likely after we came back from break.
Me and
All right. This time,
This is a bad time to ask, but does anybody want to be my site?
You said it. You said a constant what?
We gotta match card.
pressure.
I'll do it.
You just gotta look at the colors. Okay, I got it. So basically, match cards around like a group of girls, and then you do the same with boys watching.
All right. So what's going to happen?
I'll be a boy.
Well, that's good. I'm glad you're going to be a boy.
It's gonna be an alternate. I don't know.
So what's going to happen inside the container if I raise the temperature?
They gotta move faster.
Okay.
Oh my gosh.
There'll be more pressure.
Ah, and if they move faster, the pressure's gonna increase.
All right. When temperature is raised, the particles move faster, collide more often, pressure will increase.
So what does that say constant pressure?
All right. But
Now, Miss Wall.
we want it to remain constant.
So you increase the volume.
So that's the question I'm asking. So, what must happen to volume for pressure to remain constant?
It must increase.
So, whenever you're drawing these pictures, do you necessarily need the pictures, or you just need to write that the temperature's increasing with
You
particles?
don't have to have the pictures. I just like them. All right. So, most people are okay with what we came to the conclusion of, that if the temperature goes up, the particles are going to collide more often, right? They're going to move faster. They're going to hit the container walls more often. Are we okay with that piece? Okay. So we said pressure was not going to increase though in Charles' law. So our question is, what are you going to do to volume so that the pressure can remain constant? You don't want pressure to go up. You don't want more collisions. So what are you going to do to the volume so the pressure cannot go up?
You're gonna have to increase.
You're going to have to increase the volume. Okay? So
Hold on, don't start writing again.
I'm just going to write, we're going to increase the volume. Okay. We will increase the volume. And for those of us who are okay with the pictures, we will increase the volume. Now, I will tell you for the exam, you do not have to know the name of the law. You do have to for my test. Okay? You have to be able to tell me what Charles said, what Boyle and Lussac all said. You do not have to know the name of it for the exam. Now, you will have to know who's directly, who's inversely, that kind of thing.
Are you gonna
For the exam also.
just like written in exactly like this, or is it like it'll be a dummy terms? V and T.
It's gonna be smart terms or dumb terms.
Yeah.
It's hard to say. I'm not sure how dumb I have to be to say dumb terms.
Dumb is in this.
You're literally gonna put V and T are at constant for Charles law.
There could be some on the test that
Or you
are
can do something
closer
like
to dumb than
molecules
smart.
remain
Remain
idle.
Wait a minute, you can move it.
I was going to slide up for just a little. So, are they directly or inversely?
Invert.
All right, what happened to temperature?
Increase.
All right, temperature was increased. What happened to volume?
It increased, therefore it's directly.
All right, so volume and temperature are directly proportional.
Bless you.
And I'll write the law on the next board. Because we got to add in something special for the law.
What? You don't have to have them on the table like that. Well.
Are we all there? All right. So, what does Charles' law say? Charles' law says volume and Kelvin temperature are directly proportional.
This is still for Charles law.
Yep. At constant pressure. And again, I write moles in parentheses because they're not changing either. Now, this time, the formula says V1 over T1 equals V2 over T2.
Like the volume.
Now, tell me this.
Nope.
Why does the temperature have to be in kelvins?
Because it's a neutral.
That's what the science is.
Yeah.
No, I want a math reason.
Because Kelvin is big.
No,
Simple.
no.
It has a K.
No, we don't know if this is theoretical. And theoretical.
Think about what kind of number we could get.
Absolute zero. all together, she's got the number we can get.
270.
What did you say, Howard? Mm-hmm.
That's why we don't know.
All right, some kind of what number?
Some type of fat number.
What kind of number do we not want?
A negative.
We don't want a negative number, one. All right, because do we
You're
want
smart.
negative volumes?
Yes.
You're smart.
What other number do we not want in the denominator? Zero. Okay, absolute zero theoretically doesn't exist. So we cannot have zero in the denominator, which is why we use Kelvin.
This wall.
All right, it's undefined. What?
happened if somebody did find absolute zero? Like, they made that.
Then we'll know if it exists or not.
But like, what would happen?
Well, I don't know. I guess we'll find out if we ever get there.
It should spread
Bro, I'm
very
gonna do
quick.
that.
What?
All right. Whoops, too far.
What you doing this wall?
All
I
right,
didn't say I was gonna do it.
that's the first question.
I'm gonna do it.
That's the second one. Which one do you like better? That one?
Whatever one's short.
That's why I've given you the option. All right, Faith said the first one is shorter. So there's the first one.
Thank you. Like that.
Right. Yep.
Will we have questions when we have to convert the gas and then convert this?
Hmm.
Will we have questions when we have to convert the gas and then convert this?
You gotta change it to Kelvin's.
No, friend, I'm talking about the gas, like neon. Neon compared to oxygen.
No.
Okay.
Well, hold on.
Oh, come on now.
Wait a minute.
In these, no. Before we're done, yes. When we get to the stoichiometry piece after break, yes. So let me qualify that answer.
Miss Wall, does it matter what from
Miss who?
Miss Wall? I've never
I'm
asked.
talking Ms. Baldwin about a part of the day, so.
What, does it matter what can we put for 2-1 or 2-2?
They have to be paired
Match.
correctly. All right, we caught up?
No. That's what
You
happened.
said you were writing the shorter one. I thought we might have hope.
Oh, you just write like you're on crack. Not everybody do that.
I'm gonna solve it with you.
Well, that's.
I think I did this one.
I was just asking you to write it down.
I was saying.
Yeah.
I know my overachievers are trying to solve it. I'm just asking you to write it down. Thank you for waiting, Joyce.
You said we have to do it in Kelvin.
I think I did it right.
Kelvin first.
I did my part.
So we done A, B, C, Birds have
Yes.
Kelvin.
Exactly. So, for those of you who are lost, these two numbers have to stay together as a what?
B1 and
B1 and
C1.
T1. So that's 752 milliliters. 25 degrees Celsius is T1. So that means 50 degrees Celsius is what? T2. Now, the only thing that makes this different is I told you temperature has to be in what?
Kelvin.
Has to be in Kelvin.
So
So you have to make the shift and you got to change the temperature.
we have to do that before we do that.
You have to do it before you plug in. Even if the question says, what is the temperature in Celsius? You have to change the temperature before you calculate. Did everybody hear me say it?
Yes.
Even if it says, what is the temperature in Celsius?
So
It has to be done before.
So you have to convert.
You have to convert before you plug
Then
in
we just-
to Kelvins.
So if Celsius to Kelvin, it's back to Celsius.
Correct.
So then we,
So if you don't convert,
It will be wrong. It will not calculate correctly.
so then we just like, at the end, you just put Celsius back, even though we already did it.
Yep. So that's gonna be 298K. What's that? 323. Okay. Wasn't sure I'd do it right in my head. All right. So using the formula, V1 over T1 equals V2 over T2. So 752 over 298 equals V2 over 323. Now, you can solve it any way you want to.
bag up now.
I've told you before, I only solve one way in class. Done it many ways over the years. Y'all are terrible at fractions. All right?
You know? Tell that to my grade.
So I only solve one way.
Cross multiply.
That's the only way I'll solve. So 752 times 323 equals 298
Whoa. Oh,
times V2.
it's,
Okay? Now, some of you will put all kinds of weird numbers on your paper. Okay? I will not write those weird numbers on the board. Okay? They will also not be on my answer keys. I will warn you that ahead of time because people will ask me all the time, Ms. Waller, will I get partial credit? The answer is yes, you do. At the first step, I don't recognize the number on your paper. There's a deduction at that point. Okay? The fewer steps I recognize, the less points you earn.
So you want
is it?
I'm just telling you now, you don't have to show me work. The less work you show me is fine. But if you make a mathematical or calculator error, the less I recognize, the less points you earn in terms of me giving you points. Now, if you don't show me any work, it's minus 20. The directions tell you you have to show me work. Because if all you do is write down an answer, I'm going to assume what? Exactly. Okay? I have low trust. I put that out there up front all the time with teenagers.
Did you get 815?
I tell my own children that. I have low trust. Okay?
I got 815.
I assume all teenagers are trying to get something over on their parents or their teachers.
Probably. I got 815.
That sounds about right looking at those numbers.
I mean, think about it. You were a teen once.
Miss Wall, were you rebellious?
No, I was pretty honest.
That's what you say.
So you
I
were
was the
very
first child from divorced parents, so.
Well, I'm gonna lose.
All right, questions?
Wait, I need to catch up.
Did what I did make sense?
Yeah.
Yes or no, Joyce? I know it did for the rest of y'all. Ask your Joyce.
I got
I
it.
need another one.
Okay, we're gonna do another one.
815.
Or other y'all are, I'm just gonna sit here. Lunch on my dog list.
The same thing applies to this one where the units have to match.
Mm-hmm. And when you have it. You got it? Got it. All right, write this down. Now, sometimes we use shorthand.
Well, I like the word.
Because we get lazy. STP means standard temperature and pressure.
Stop.
Okay? So what does standard temperature mean? It means 273K.
So that means it's T.
This means it's 273K. So instead of me writing, like I did here, and I told you the temperature was 25 degrees Celsius, I might just say standard temperature. So if I say the word standard temperature, you have to know the temperature is what? 273K.
Oh.
Okay, but I might not write 273 in the question. I might just write the words standard temperature and expect you to know it's 273. All right, or I might say standard pressure instead of writing. I didn't use pressure there. earlier when I did it, it was 1 ATM. Okay?
So-
I might just use the word standard pressure.
But for these questions, are they only going to give us one set, or how are we supposed to find the other set if we only get two numbers?
We're going to get to one where there's 3 numbers. We're not there yet.
Okay, so how do we 274? Oh, is this not a question?
Uh-uh.
Oh, I was like, how are we supposed to solve this?
You're not solving.
Got it. I was confused. Because you said
All right.
next
Is
question.
everybody have it?
Yeah.
Now, let's say I'm Faith, and I forgot this on my test. I read this number, and I'm like, Paul, you know I don't remember this. Where can Faith find it? It's on the reference table on the front page. You can look it up.
Yeah, 273.
All right, y'all find the answer for me. You already have it. You already have one written down. Find me the answer. Just solve it.
What y'all?
Find me an answer.
Okay.
All right, Allie, find me an answer.
Oh. So, the hardest thing.
I already know I'm gonna forget to convert it.
Oh, crap. Yep. Do you have an easier way to recognize if it's either Boyles or Charles?
See how it says up there? Nothing about ATMs. There's no pressure anywhere in the question. That's how you know that it will not have pressure. So when you go to write down,
So it'd be Charles.
So if, let's say you went to use this formula.
You wouldn't have.
Well, you would have questions.
Yeah.
Okay, you don't have a pressure to plug in because there's no ATMs, there's no KPAs, there's no pressure units anywhere in there. Does that make sense, Annabelle? Okay, that's how you would know it was not Boyles. Uh-huh,
Whenever we're doing convert it back to Celsius,
uh-huh.
do we have to convert it back?
In that question, does it say the temperature in Celsius? I wouldn't convert it back, I'd live in Kelvin. Unless it said, what's the temperature in Celsius? I'd leave it in Kelvin.
Can I do it on the board as well?
Mm-mm.
Why? Let me do it on the board.
No.
Okay.
All right, can we look at what you came up with? Joyce, how'd you do?
So I didn't finish it, but it's a little more confusing what I got. So.
All right, so what's your first volume?
275.
What's your first temperature?
Maybe 20.
Okay, what's your second volume?
226.
What's your second temperature? Good. What'd you do with the 20?
The 20,
Yep.
we have to convert it to Kelvin.
Good. What do you do? Plug it in.
So we're not.
No.
Why would you?
Anybody confused on how I got that?
Nope.
Anybody confused on how I got that? Faith, you okay with how I got that? Anybody okay with that?
No.
No?
No.
Okay, backtrack. All right, so what's V1? What's T1? Okay, V2? T2?
We don't know.
Okay, what am I doing with that 20 degrees Celsius?
Changing it to cold.
So add 273, that's 293K.
Oh, okay, whoa. That's what.
All right, so my formula is V1 over T1 equals V2 over T2. So V1 is 2.75, T1 is 293, V2 is 2.46, T2 is that. That's what I had before I asked if everybody was okay with how I got it. Are you okay with where I got it now? Okay. Cross multiply. 2.75 times T2 equals 293 times 2.46. Divide over here by 2.75. Divide there by 2.75. T2 is going to be what? 262. The unit has to match, so this was in Kelvin, so that means that's in Kelvin. Now, for those people who were listening a minute ago, did the question say to change it back to Celsius?
No.
I would not change it back to Celsius. I would only do that if it said change it back to Celsius. Okay?
A negative number.
What? Yes, you could get a negative number. If it said change it back to Celsius, it's very conceivable it could be a negative Celsius number. Yes.
So if we change what Celsius, the question is asked, so if you're wrong.
No. Any other questions? All right, last gas law. Last gas law before we do the combined gas law. All right, so Gay-Lussac, the combined is easy. You don't have to know all the reasons for up and down. Now, Gay-Lussac is probably the one y'all actually know the most about. Gay-Lussac is pressure and temperature at constant volume. Now, if you've ever played with an aerosol can and a flame when you shouldn't,
I don't do that.
talking about tires on the road and measuring air pressure after you've driven on them, all of those are Gay-Lussac laws. All right, if you have all right, and I'm only going to draw one this time because this one's a pretty easy one to understand. Okay? If you increase the temperature, what do you know is going to happen to the particles inside the container? All right, the particles move faster. So if they move faster, what are they going to do more often?
Bump into each other.
All right, they're going to collide more often. Now, if they collide more often, what happens to their pressure? That's right. Pressure will increase.
So that's when we wouldn't have any volume.
No volume on this one. It's constant. All right. So if you increase the temperature, the particles will move more often, collide more often, pressure will increase. This is why I said Gay-Lussac is the easiest for everybody to understand in terms of how it works. So if you increase temperature, pressure will increase. So is this one inversely or directly proportional? So pressure and temperature are directly proportional. So to write this law, again, it's worded almost identical to Charles' law.
I don't really like it.
Well, I can't fix that. Pressure, and again, we have to qualify it because it's temperature. We have to say Kelvin pressure and Kelvin temperature are directly proportional at what has to be constant, volume, and then again, I'm going to say and moles in parentheses because we're not doing moles right now. Now, the formula is almost the same as the one we just did, except that it's P1 over T1 equals P2 over T2. All right, so these formulas are almost identical because the law is almost the same. They're both directly proportional. The only thing that we I'm going to see my mom this weekend, so I'll be there Friday to Monday. I haven't been home since Christmas, so she's really pissed. Elizabeth City.
Where is that at? Yeah.
Well, it's almost to the Outer Banks, so it's about, I can do it in about 4 hours, 40 minutes.
Go here vacation. No.
Well, I was going the weekend, but my husband had retinal reattachment surgery. We were leaving that afternoon after school. So, yeah, change plans. Change plans. All right, does everybody have what they need? All right, do the two problems, tell me which one you want. This one or that one?
That one.
Okay.
This one's probably harder and it's just shorter words. That's why I gotta choose.
I don't care. It doesn't matter to me. I just use the other one for y'all to practice, but it doesn't matter to me at all.
Wait, is there an option?
Come up with this, like, is there a different one? That's like shorter.
They're both mine.
This is the shorter one. P1 over T1.
I just have this one is shorter to right. I'm fine with it. It doesn't matter to me which one we get.
Over T2.
My life was basically the same that they were.
They both practice gay Lussac's problem. So I don't care. No, I wish I was going on a cruise or something fun, but I'm not.
You just have to write
Have you been on one before?
All right.
Right.
Shelby has a trip to DC for a school trip. Ian's got to go to school Thursday and Friday.
Yikes.
He's going on.
Hey, at least you have 2 days to yourself.
He's good friends with my daughter.
Ms. Wall, I think you're most excited about having time to yourself.
2 days with them in school are gone, and it's pretty exciting. The only downside is I have to get up and take him to school.
You better tell them why.
I'm thinking he can ride the bus home Thursday and I'll pick him up Friday. I'm not thinking I'm sitting in that car right line 2 days.
Wait, Ms. Wall. Wait, she's still at the middle school?
He is.
But she'll be on a trip.
She'll be on a trip.
So,
Yeah, normally he
she's
brings
T2,
it up.
T1, T2.
Mhm.
And so the P1 is the.
Yep.
And then the
All right, can we look at what you got? Does everybody feel they can do it themselves? All right, y'all do this one. And then we'll talk about it.
Yes, ma'am.
Okay. I have to rewrite it.
Monday's gonna be 78 degrees. You know,
I'm just pissed because I want to be with the coldest day out of the whole week.
Tuesday's 81.
I'll be there.
Oh, I might not be at work. I might just be out. Fuck that. But Friday's storming. I love storms.
I know how to do this. How are you doing?
I think you know how to do.
I'm done. Emma, what's the answer? How many digits do you have? So like you have a
She's calculating and me, so I've got the answer.
Right.
All right. Let's talk about what you came up with. So for the question, what's P1? 1.8. All right, so we've got, change colors here. So 1.8 at 20 degrees Celsius. Are we okay with that? So P1 is 1.8 ATMs. 20 degrees Celsius is T1. All right, if we keep reading, we have 1.9 atmospheres again, so that's going to be what? P2. Everybody's okay with the fact that they match, so we're not going to need a unit change. And then T2 is what we need. Okay? Everybody's good with that?
Yes.
All right, so looking at our temperatures, are we good with the units we have?
No.
Got to change to Kelvin. So 20 plus 273 is 293 K. All right, P1 is 1.8. T1 is 293. P2 is 1.9. T2 is, we don't know. Cross multiply, we get 1.8. T2 equals 293 times 1.9. Divide by 1.8. Divide by 1.8. Can somebody tell me what T2 was right there? 309. All right, so 309, the units have to match. So that had to be a Kelvin. All right, the question said temperature in what? Celsius. So K equals C plus 273 is our formula.
Oh.
That was in Kelvin, so 309 equals C plus 273. So we're going to do what to get C? Subtract. So what's 309 minus 273? 36 degrees C would be our answer. Questions? Feel okay about that?
Yeah, I just forgot.
So,
I'm gonna write that at the top of every test.
You left it in Celsius?
all of the equations is like switch back to Kelvin.
Guys, I can't hear Raquel. Every,
So for every equation, you would have to change it to Kelvin, despite it asking us Celsius.
correct,
Because then if you don't, you get the wrong answer.
correct,
Even if you just leave it at Celsius.
correct. Correct. Anybody else? All right, last law. All right, let's go back. The last law is called the combined gas law. It combines Boyles, Charles, and Gay-Lussac. All right. So the only constant is moles. So if it combines those three laws, the only constant is moles.
Ugh.
Not.
Let me rip from my papers.
The only constant is moles.
Oh, are we gonna finish this in 10 minutes?
Yes. Do you know Miss Wall?
What?
Does she know Miss Wall? You get that shit.
No, we're going to finish it in 10 minutes. The formula is P1 V1 over T1 equals P2 V2 over T2. Now, this is the only formula that we've done today that's on your reference table. Maybe somebody's mowing the grass. Unless you're talking about a different kind of grass, and so that's not the case. Now, the cool thing about this formula, and it's the only formula that works this way. Let's say that we're Nadia. She has a moment on the test. She's like, oh my God, I forgot Boyles' law. I don't remember the formula. But she remembers that it's constant temperature. And she just doesn't remember the formula, but temperature's constant. She can simply erase temperature out of the formula in the combined gas law, and she has Boyles' law.
Wait,
Then
what?
you can do half
Friend.
Now, if you remember that Gay-Lussac's law is constant volume, but you don't remember the formula, but constant volume needs to go, you can take out volume, and
So
you
the-
have Gay-Lussac's law.
So the main one we need to
Okay.
memorize is this one.
You don't even have to memorize it, because where did I just tell you it was?
On
Oh,
your
that's
reference.
dummy lit.
Okay?
No, you should have taught us this one first, honestly.
Now, write it down and we'll solve. Because, as you pointed out, I have 10 minutes.
Let's hurry it up. Just all this in. Well, just all this in.
No one else is talking for it.
Pink.
Purple. Yeah, I do in blue. Need something a little more contrasting.
So there's no way that's the P, right?
All right, do we
No.
caught up?
No.
I wasn't going to give y'all time to solve. I was just going to do it.
Oh,
Given the amount of time we have, I was just going to go ahead and solve.
go ahead. No, because I want to try it.
I appreciate that you want to try. I'm going to give you homework to try. All right, but given our limited time, I wanted to go ahead and do this one. All right, so when you look at this one, instead of us having a couple, all right, these are going to come as triplets. So when you read this, see how you have 50 liters at 25 and 820? Those three numbers have to do what? They have to stay together. It doesn't matter if you make them the ones or the twos, but they have to stay together. So the 50 liters is a what? Liters is a what? Is a volume. All right, now, notice I didn't specify this time who's a volume, who's a temperature, who's a pressure. This is why I told you had to recognize your units. All right, so liters is a volume. What is 820 millimeters of mercury? That's a pressure. And 25 degrees Celsius is a what? That's a temperature. All right, V1. So we got to have a V2. We got to have a P2. We got to have a T2. All right, so what's 10 degrees Celsius?
250.
Oh, I just meant temperature. 650 millimeters of mercury would be a what? P2. And that means we have to be solving for V2. All right, do my units all match? Yes. Which one has to be changed? Celsius. All right, so 225 will be 298. And 10 will be 283. Okay. We're good to go on the pressures and the volumes, but we do know our volume will be in liters. So, using our formula, V1 P1 over T1 equals V2 P2 over T2. So my first volume is 50. My second pressure, or first pressure, sorry, is 820. And my first temperature is 298. V2, 650, and 283. Is everybody okay with just plugging in numbers we came with? Say what?
I think I wrote the wrong formula. V.
You put plus in there?
No, like, I put P before B.
Oh, it doesn't matter. It doesn't matter. It's the same thing. If you write P1, V1, it's the exact same thing. Half the time, Joyce, if you pay attention, tomorrow I might write it as P1, V1. Okay? I have a tendency to flip those letters all the time.
Well,
What?
do we have to round in these? Because I'm spelling it a little different way. And do we need to round?
You can. It doesn't matter. If you do,
So like if we're like
if you
one
do
away-
that, if you round, you will be off from what I have, and that's fine.
Okay. Well, I did.
Because I won't actually use the calculator to the end, so mine won't be rounded. So cross multiplying, I'm going to have 50 times 820 times 283,
I'm trying it out the way that I wouldn't do it on the intense, so we're gonna see.
298, V2, 650. So to get V2 by itself, this time I have two numbers. So what am I going to do? Divide by both. So divide by 650, divide by 298. Divide by 650, divide by 298. And we should be able to find V2. Anybody done it for me already?
Yeah.
59 point- 59.9 or 60? Okay.
I put 59.
So 59.9 or 60. I'll just write 59.9. My unit will be liters. Issues with how to do that? Yes,
So I
ma'am.
can do it this way.
How to do it, but like, do we use significant?
This is why I told you, as long as you're within one, I'm good. Now, if you write down 59.98764 off the calculator, oh yeah, I'm taking off for significant digits. Every day of the week.
Does this work?
Now, this is why I told you, if you do this and your answer's wrong, that's the standard deduction. I'm going to write algebra and minus whatever.
Why?
I'm just telling you. I'm not going to try to figure out what your answer is or how you got it. The answer's correct.
No.
As long as it's right, I'm going to put a check and move on because you've got work and the answer's right. But if the answer's wrong, I'm writing minus something in algebra. You don't have to do it that way. I'm just telling you I'm not going to try to figure out why your answer is wrong.
Do you have homework?